Implementation of hidden Markov model. A hidden Markov model is a statistical model used to describe a system where you have a sequence of observable events, but the underlying process that generates the event is not directly observable. We have the objective of the experiment, program implementation, execution, and application in the presentation. Objective of the experiment. The hidden Markov model or process is a Markov chain going from one state to another but cannot be observed directly. The hidden process is observable and depends on the hidden states. The goal of hidden Markov model is to capture the hidden information from the observation. The objective of hidden Markov model is to model a sequence of observable data where the underlying process generating the data is not directly observable but can be inferred from the observed data. The diagram showcases the states and its probability. From the given diagram, we can infer there are two states or the hidden states called the rainy and sunny, and we have two observable states called happy and sad. From the given data or from the diagram, we can tabulate transition and emission matrix. The another given data is the initial probability, that is 0.5 and 0.5, and the sequence of observable states happy, 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 sad, sad, and happy. For the program implementation using Python, we import the most basic library, the NumPy. This supports most of the mathematical operations that we are about to perform using the matrix and the array. Defining the model parameters, that is transition matrix, emission matrix, initial probability, observed sequence, initialization of alpha matrix, calculating forward probabilities, finding most likely sequence of hidden states. The transition matrix is a matrix that represents the probabilities of transition between hidden states. Each row corresponds to the probability of transitioning from one state to all other states. The emission matrix represents the probability of observing each possible observations given each hidden state. Initial probability, this array represents the initial probability of being in each hidden state at the start of the sequence. Observed sequence array contains the observed sequence of the emission. Now, the initialization of alpha matrix will be initialized with 0. Here we initialize the alpha matrix that will store the forward probabilities for each time step and hidden state. Calculating forward probabilities. You calculate the forward probability using the initial probabilities and emission probabilities. For subsequent time step where t is greater than 0, you iterate through the observed sequence and compute the forward probability using emission probability and transition probabilities, considering the previous alpha values. Calculating the probability of observed sequence, we sum over the final row of the alpha matrix and obtain the largest out of it. For each time step, we compare the alpha values corresponding to each hidden state and choose the maximum probability. Based on the computation, we can construct the most likely sequence of the hidden state. To implement the hidden Markov model using Python, we import NumPy for the mathematical operations to be performed on array and the matrix that we're going to use. We are using the transition matrix, emission matrix, initial probability array, and observed sequence array. And initializing the alpha matrix to 0, and we'll be calculating the first row of alpha matrix. After calculating all the rows of alpha matrix, for calculating the probability of the observed sequence, we use the last row of alpha matrix. We'll be printing the probability of observed sequence, and to find the most likely sequence of weather state given the observed sequence, we will be comparing the alpha values and we'll get into the highest probability from the compared values. Application of hidden Markov model. They are used in speech recognition and face recognition, where certain parts of the speech can be called as the hidden states, and the observed or the known values can be known as the observed sequence. Similarly, in natural language processing too. Here, according to the diagram, we see that there are few values that are missing between y3 and yn, and those are the hidden states.